Okay, stream should be live. Let me make sure the chat works as usual. I think it should be fine. Let me just test. All right, sweet. Hey, how's it going? That was quick. I just went live. Just making sure the chat works because last week it wasn't really working in the beginning. But I think we're good. Nice. Nice. Yeah, I'm not sure if you were in here last week, but I'm basically picking up where I left off. So the goal today is to basically get. Yeah, I thought so. I thought I recognized the name. Oh no, what happened? Wait, what's this error? Does not take 0 arguments. What? Oh, I'm not including that in here. Interesting. Okay, yeah. The goal is to get the water simulation from here. Actually in the game this time. So, it's gonna be kind of a project though. But I did a lot of the heavy lifting stuff ahead of time. So it shouldn't be too bad. Yeah, it's working fully now in the with the new chunk system. Well, basically last week I made it so all the water simulates like based on chunks rather than just like a giant volume. So that's working now. So I can like disable chunks, and you can see like the water actually only basically simulates within chunks. Yeah. I had it like mostly working at the end of the stream last week, but I had to finish some stuff the following day. But yeah, it's like fully working now. So, and then I started messing with physics a little bit. That's probably hard to see in the stream, but I have like this little ball guy, this little zero mass little object that floats on the water, but I didn't actually finish that, so I might do that soon too. That was kind of tricky because like the CPU has to get the water simulation data so it can actually do physics with it. So yeah, I did all that after stream last week. But yeah, so in the game, I had to change the lighting because the lighting is also a simulation. So I basically had to do the same thing I did with the water, but with the lighting. So I went ahead and did all that. So most of the groundwork is here for that. Like if I show the render target, like this here's basically the lighting simulation like data. So like obviously the white is like sunlight, and the gradient here is like the light leaking into a cave. But you can see it's like broken up, basically kind of randomized in chunks. So yeah. The goal is to take all the code in this separate project and get it in here. And yeah, I'm kind of just like talking right now because I just started. I need to like get in the mindset of doing this. Yeah, because I have basically this project. There's just a lot of code in here. So like all of this stuff is this thing, right? This little project. And that's separate from the game right now. So I basically need to like re-implement all of this just within the game now. But like most of this I can just copy and paste. There's just like some stuff I need to think about. Because in this little project, I like made a separate chunk system. Because it's like separate from the game, right? So I had to like kind of do a bare bones chunk thing. But the game has like a more proper system for that. So like some of this code I'll need to actually like think about. But I'll just get started with the render targets. Let's see. So like this is like easy stuff. Yeah. My goal is by the end of today I'll have the water in the game. So we'll see how that goes. So I'm just gonna start copying and pasting stuff and see what happens. So I need all of this. Yeah, I think that's it. I just need all of this stuff. I should get this up in a separate window. I can close that. I'm just glad because I know like all the hard stuff is done. Now it's just like nitty gritty kind of get in there and do it type stuff. So copy all that. We'll probably have a lot of errors. Yeah, we do. Yeah, so it's kind of annoying stuff. Like I have like just random macros like resolution. It's like, all right, I need to be a bit more descriptive than just resolution now. I can't just say that. Because like resolution can mean a lot of things. So what is the resolution actually? Yeah, so that would be this one, I believe. What's that? Yeah, okay. Oh yeah, and then I also multi-threaded the chunk generation this week. And I realized there's a lot of issues with that. So I'm gonna have to do that today too, potentially. What is microblocks? Okay, I already have this one, so we don't need that. So yeah, I remembered how much I hate multi-threading things as well. So readback is just... So I guess the readback buffer should be separate from this. It's like up here. And then long term, these things won't even be macros because these are not actually constants. But one thing at a time. Yeah, it's like, I could talk about my issues there for a little while, but so like I was like relying on just null pointers in my chunk code to like denote whether the chunk exists or not, like if it's allocated, which is fine on the main thread because I like know the logical order at which things can happen, right? So like if the chunk is not null pointer at this step, it will always be valid. But obviously once you multi-thread, you no longer can make those sort of assumptions. So like in the second, like the thread that's doing the chunk generation, it's like checking if the thread exists or if the chunk exists. And it'll be like, yeah, it exists still. And then the main thread will actually like reallocate something. And that pointer is just, yeah. That pointer is no longer like useful for that. So I have some ideas how I'm gonna fix that, but it's just like, it's really nice writing prototype code where you don't need to care about that stuff, but yeah. And I'm not like a multi-threaded threading guru either, so I'm not excited about fixing that. Okay, so man, this is hard to see what's happening. Yeah, same. Yeah, because like the easy solution for that is, yeah, you just like add lock around everything. It's just annoying because it's like only in like specific situations where I actually need the lock. But the code can run in like other hot paths on the main thread that obviously don't need the lock because, you know, it will never be in contention. So it's like, well, do I just create a second version of the system that like is thread safe and use that one during generation? But then you have like duplicated code that does basically the same thing. So like realistically, you probably just do the lock and it's not even a problem performance-wise. But just kills me. It kills me to do that. Okay, so we need to do these. Someone's like running around upstairs. All right. Yeah, hopefully this should get interesting soon once I get all this like boilerplate stuff done. Right now, this is kind of dry content, I think. I was kind of surprised people were even watching last week, because like I spent like 3 hours trying to figure out why the data wasn't getting sent to the GPU correctly. Only to find out it was just like some forced alignment issue. Okay. So I spent 3 hours just to like basically change nothing and just change my alignment. Okay, let's see. Guess I don't need this one here either yet. I'll add it just for now. Yeah. Okay, so I have all of the render targets initialized. Now I need to free all of these. Delete this one. I don't really have many thoughts on Python. I don't use it very much, to be honest. So, a bit of a non-answer, I guess. I like Python when I have used it. Sometimes I actually find it harder than C and C++, because like sometimes I'm just like left guessing sometimes what my variables are, or like where they are. I'm very used to the paradigm of like everything has like strict types, and things have like declarations and definitions. Oh, what am I doing? Sorry if my answer is not very good. I'm like deep in the flow right now of getting this thing working. I memorize the stuff that's like worth remembering, and I look up a lot of stuff that I don't need to memorize. Like the one nice thing about writing the engine basically entirely yourself is that you know like everything that's in it, and you just like know, you know, the logical flow of everything from like compilation to like the game running. But like I don't like when I'm implementing something specific for like an operating system, like creating the window or something like that. Like I don't remember how to create the window in Windows or Mac. Like that's something I look up while I'm writing that code, and then I just forget about it immediately afterwards. And same with like graphics stuff. Like I'm not remembering like all the DirectX 11 like descriptors and stuff. That's just something I look up when I need to do it, and then just immediately out my brain afterwards. I think maybe the one bit of advice though I do have on that is like if you follow kind of the same patterns everywhere with how you implement stuff, then like it gets really predictable how to like read the code and solve problems, because you kind of always just do like the similar sort of patterns. So consistency is really important, I think. Especially when there's like a million different ways of writing code out there, and people have their own styles. Like there's no like best style, I think. It's just pick the style that works for you and then just keep doing that. I mean, there are some styles that are objectively better than others, but I don't know. Once I stopped caring about whether what I'm doing is like the optimal way of doing something, it's like I've had so much more fun programming, because like I don't know, I don't care. I'm not trying to optimize every little bit of my code. Okay, so that still compiles, I think. I'm making a game right now. So like I'm making the engine for fun, but I'm also using it to make a game. But like the game project isn't super serious. Once I fix this compile thing, I can show you the game. I can give you some context to like what I'm actually doing right now, because I know I'm kind of just here doing random stuff with two windows open and compilation errors because I didn't name something correctly. Yeah, like what's the problem? Fluid uniforms. Do I even need that? What do I use this for? Oh, I do use that. Oh, that's annoying. Where was that? Okay, yeah, here's the game I'm working on right now is like a Terraria clone, basically. It's like early days. I just started this last month. So there's like literally nothing to this game right now. Yeah, I think I'm going to expose it. It's pretty powerful too. Like all this like, so this DV thing stands for like development variable or debug variable. And what's cool is I can like hook it into just any variable in the game. So like, and I have these little windows that show up if it's like the variable represents a render target. So like I can actually just see like what's in the render target. So if I go to like, I don't know, this is the buffer that contains all of the like the block data for the GPU. It's cool because I can just like see this instead of opening up render doc. I've been working with C++ for like 5 years, I would say, in like a serious capacity. I use it at work. Well, I was kind of like forced to use it at work, my first job. So that's what made me like switch to C++. Okay, let's see. So we need these other chunks too. Let's see. It's kind of tough like juggling 2 projects at the same time. How do I get rid of this? Hide. If I finish the game, yes. Oh, but yeah, like I was trying to show you. So this is like the game that I'm working on. And then I spent like the last couple weeks writing a fluid simulation. So it's, this is it. You can like place water and lava and oil. But this is like currently in a separate project because I was just like really focused on just getting the physics right. And like, I don't know, there's a lot of nuance to a simulation. So today I'm working on getting this simulation actually integrated into the game. So there's like a lot of just really rough stuff I did to get the simulation project to like kind of mimic the game. But I need to actually like go in and integrate everything properly now. My first goal is to just get the simulation working in any capacity. So, oh, this thing keeps popping up. It shouldn't actually take too long to do that. I just need to sort of get the code in and fix what needs to be fixed. Because I had like a sort of a debug chunk system in this project, but I have a real one in the one over here on the right. So what's nice is they're both made in the game engine. They're just like different projects. So like the amount of code I actually need to change isn't that significant. But let's see, where's the job? So like this should actually get water to simulate, but nothing's gonna happen yet once it's working. Yeah, it's just like all of this stuff is a pain. That's hard to say. Yeah, because when I worked at the AAA company, I was in the graphics team. So I did a lot of engine stuff, obviously, as part of the graphics team, because it's like fairly tightly integrated to the engine. But all of my portfolio was just filled with like graphics related stuff. And like past games I made. I'm not actually sure what you'd need to get into like the engine team specifically. I mean, the easy one is just like maybe make a game engine and like a game in it. Because if you do that, you're sort of forced to do like everything you need to do for like an engine position. Though it depends on the company too, because a lot of companies now, they use like Unreal Engine. My current job isn't. I actually left. I left the games industry for an adjacent job. So I'm still doing graphics. I'm just not in games anymore. But I used to work at a game company. I worked there for a few years. And I actually enjoyed it. I did enjoy working there. So like, I don't know, people have a lot of horror stories about the games industry. I thought the company I worked for was, I don't know, really well run. I just didn't like the actual work itself, I guess. So like my complaint is that when you work at like a big company, you're kind of just like forced to do specific, very narrow things. Like I was on the graphics team, so I was just always doing like graphics stuff, and that's it. I couldn't do stuff outside of graphics because it's like a different team does that. But I like to kind of do everything. So I'm like, I love graphics stuff, but I can only do so much graphics stuff before I get like bored of doing graphics stuff and I want to go do something else for a while. But when you're on a big team and you're like hired to do graphics, it's kind of like you really have to love graphics specifically, and that just wasn't me. Okay, so let's see. Well, yeah, it was like shaders and stuff. Then like a lot of just like engine things like tangential to graphics. So like asset streaming, like LOD stuff. A lot of just debugging. We worked with all the consoles too, so it's like, I don't know, getting in on like the PlayStation and figuring out why like the shader doesn't work on the PlayStation. And it's like some random nuanced detail about how like Sony does their shader language. I don't know. It's just like really tedious work at times as well. So yeah, it's really all I have to say. All I have to say on that. I could say more, but I'm sure it heavily depends on the company too. Like I'm sure some companies give their engineers a little more freedom. But the company I work for had sort of tight deadlines, so you kind of just had to do what you were assigned. Okay, so what's wrong with this? Yeah, I agree with that actually. That's like my worst part of game development is assets, because I have basically zero artistical talent. So like the sprites we have in the project now are like old sprites that someone else made. Hey, how's it going? So yeah, I'm kind of scared. Like that's one of the main things. Like I'm fairly confident in my programming ability to get things done. But when it comes to like creating pixel art or like 3D stuff, like 3D assets, I'm like heavily reliant on yeah, programmer art gets you in the somewhat there. Yeah, I'm heavily reliant on people that are more artistically inclined than me. Okay, so we implement this. And you know, okay, I can say that. No, I broke the compile. I was gonna show. Let me see if we get the assets. I did make one thing I'm somewhat proud of, but I still think it looks bad. Where is it? I made these mountain parallax sprites. This is my own programmer art right here. There's 4 colors, 4 shades of gray. But you know, I was pretty proud of my shape. You know, like I may or may not have heavily looked at pictures as reference material, and this may or may not have taken me like 6 hours. But yeah, and that's the other thing too. It's like I could practice to get better at pixel art. Like if I spent time, I'm sure I could learn to get like, I don't know, at least somewhat decent stuff. But there's like a ton of stuff I need to get done outside of graphics. Like just the programming stuff takes forever. So like, can I realistically spend like a full day doing mountains? I don't know. I don't know if that's good use of my time. So for me, I think the vision is eventually I'll like hire somebody to make art. But I want to actually like get the game further along before I start paying, like spending money on it. Code the mountains. Yeah, I need to create a. You say that, but I'm honestly thinking of like for the clouds. I'm like toying with the idea of potentially generating the clouds like in a shader and then running a pixel art filter over the results and just generating cloud sprites sort of dynamically. Well, I think that would be cool if the clouds kind of evolve dynamically like that. And that's at least something I think I'm capable of doing. Like I can write a shader that generates clouds. I can't actually just draw clouds. Yeah, that's a good point too. Like I think of like Stardew Valley. I think all of that was programmer art, wasn't it? If I remember right. Yeah. It's just like art in general too. It's like you need to like understand like light theory, you know? Like where do you even shade stuff? Like I've seen pixel art videos where people draw like rocks and stuff. And they like shade the side of the rock that, you know, that's where the shadow is. But like all of these people just seem to like know where to put the shadows to like get the shape of a rock to show up. But then like when I come with a blank silhouette of a rock, I'm like, my shadow doesn't, I can't get a shape of a rock to appear despite like my best efforts with shadows. So I just like can't visualize shadows in my head, I guess. I don't know. I'm sure that's something I could learn like through practice, but it's tough. It's really tough. Okay, so what was I doing? I'm getting lost. So it needs to be this. Yeah. Yeah, like I said, the dream, I think I need like a team. I need someone who's just like really good at art and like passionate about the game. Because if you have those two things, like I can take care of the programming, but the art and the art is really important too, because like that's what people see when they play the game, and that like the appearance of the game like really does matter. So like the art is very important. Which I hate to admit as someone who likes programming. I like to just pretend that I can make a great game just by programming it to be good, but doesn't fully work that way. Okay. What is it mad about this? What is this crazy error? Yeah. I agree with that. I mean, just think of all the games out there that look really good, but they just have nothing to them beyond how they look. But people like that stuff. I can see why. Wait, so what is the error? What's happening? Okay. Does not take one argument. What are you talking about? Where am I passing this an argument? Oh, yeah, what am I doing? I don't know why I just did that. Okay, in theory, the simulation is running right now. Though obviously I'm not gonna be able to see anything because there's like nothing to see. So let's get some stuff in here. Oh, actually this isn't fully true. What is this one doing? I've got this like so muscle memory down. I don't remember which mouse buttons places the liquid and which one deletes it. Okay, so left press, yeah, that's the one I need. Not yet. That's what I'm working on today, actually. We're getting close. Yeah, I had to do a bit of work during the week in preparation for this, but it wasn't very interesting. Yeah, you must get a bottle of water and pour it in your computer. When I was younger, I actually killed one of my computers when that happened. I had a glass of water on my desk, and I used to have my computer beneath my desk, like on the floor. And I knocked the water glass over, and you can imagine what happens next. The water kind of dripped like a waterfall right into the top of the computer case. And I think it landed on the GPU. And then my screen went funny colors, and then, yeah, that was it. Yeah, so ever since then, I have, well, I actually have a computer on the floor right now, but that one I don't care about. Ever since then, my main computer sits on the desk or in an elevated position where, you know, upstream of any potential liquid flow. Because I learned that the hard way. That was a very traumatizing moment for me as a, like, 14-year-old. So what's happening here? Yeah, so like I need to change this. This function isn't correct. Let's see. So it's like random things like this I need to come in here and fix. Chunks.get. Yeah, some of this chunk code, I really just need to like figure out a better way of writing some of this stuff, because this is not working too well. It just kills me to have all these random hard-coded values too, like divided by 128. Like, why is it 128? I know why it's 128, but magic numbers are scary. Okay. In theory, that is almost all I need. Circle. I just need like all of these sprites. I don't know what's happening. It won't run. Okay, moment of truth. Will this do anything? I don't even know which one to look at. This one maybe? Yeah, that doesn't do anything. That should have something in it. What about this one? I think once I get this code working, today's gonna be a big code cleanup day. I'm overdue. So this should definitely have something in it. I'm not sure what's happening here. Why is this empty? Interesting. So what target is being used here? Mass. Mass, this one. Okay, so if that was working, I should be seeing something in this target, I think. Well, I know that's true. I should be seeing something. Well, it's drawing with 0 transparency too, so let's fix that. Yeah, I see nothing. Okay, so why do I see nothing? Is this potentially not running? Let's just force something to draw. Okay, so yeah. Okay, so the fluid technically does work because we can see it here. Look at that. It doesn't seem... Oh, actually, that seems fine. So it's just this function here. This one doesn't work. So why doesn't that work? Let me think. If I do... Just some rough and dirty debug code, of course. Well, no, let's just not do debug code. Let's just actually think about this. So it's either not calculating the position correctly, or... yeah, that's probably it. What are these values? Make sure these are what I expect them to be. So that's a double... Put it on the block as well. Oh yeah, this function is just not gonna work. Oof, that's sad. So let's see. So the expectation for this function is that it's in coordinates relative to the Creeper World vibes. The simulation that's coordinates are relative to the simulation resolution, which isn't actually what I want it to be. So this should be, let me think. These coordinates should be like relative to the, I guess, chunk. Like just world coordinates. So you pass in like a float. 16, 32. Oh yeah, I think I just need to do that for now. Oh, that's in uint. Yeah, this shouldn't be using floats, is basically what I'm deciding. I'm trying to think. There was a reason I did that though. Because basically the function that this is doing is like when I click the mouse, it's like spawning water. But since the world is actually broken up, I can't show the debug, can I? Since the chunks are actually broken up, like, interesting. 1 second. Let me change something in here so I can show it better. Okay, so say I have these two chunks like simulating liquid, and I just like place water in between them at the border. The actual simulation looks like this. So like this chunk is like simulating up here, and this one's like to the right of it. And that's what it looks like within the data layout of the simulation, like the larger simulation volume that's being broken up into chunks. So like when I cross over in between, half of the fluid has to be spawned like here, you know, the top half of the circle, and the other half has to be remapped to be spawned in over here. And I think the way I designed the function was that it just worked generally with any sprite. Because this isn't the only thing that I do this for. And like everything else renders using floating point, you know, positions. So I just use floats. But this is the function that's currently not working because I made assumptions in this little test project about what the coordinate space is. And that's why today's gonna be a code cleanup day. But first, let's just get this to work. Because I just have like a lot of random like magic numbers here, like times 128. This might work now though, let me see. Well, I don't think it's gonna work yet. Let me change something. Where am I? So I think I actually need to change that. Yeah, because it's really annoying. You bring up a good point. Everything should just use the same coordinate system. Yeah, exactly. Okay, so let's see. Yeah, here we go. I think it works now. It's hard to see because I don't actually have the water visualizing in the world. So you just have to like trust this. Something's weird though. It's like probably impossible to see this on the live stream, but there is water being spawned into this little actually it's not working. There is liquid simulating there though, but I need to fix that because it's actually not working. There's like two things going on. So it's colliding with the wrong stuff first and foremost. So this needs to be changed because I think the alpha is actually what I should be reading here. Oh, that is fine. I don't remember which one I used to denote a solid block. They're all one giant render target. It's just segmented into chunks. Yeah, see, that's not, yeah. See, that would be a problem if I was using separate render targets, but that's, I've handled that already. So like, if we look at the block, so this is like the buffer that represents basically all the tiles, right? So like if I delete from this, I wish I could make this bigger. It's probably like really hard to see. If I delete tiles, like we're kind of looking up here, how it's like, you know, you can see like what I'm doing to the world. But this is all just one render target. And it's just segmented into chunks. And as I like teleport around, you see how it's like kind of redistributing itself. So it basically reuses these like a giant pool of like simulatable region. And the same is, the same works for the lighting. So this is what I did earlier in the week off stream. Like if I go to the ambient lighting one and I like teleport around. So it's like simulated in a pool in one render target. But then yeah, it has to resolve like where the neighbor chunks are in UV space. So that was kind of like one of the things I was figuring out last week on the stream. But that works now. But now it's like when I basically paint in a large circle of water on the border of one of these chunks, it needs to know how to split that sprite essentially, because I'm just drawing sprites in a circle. That's like water. It just needs to know how to like chop up that sprite and like remap to the various places. So for instance, if I go back into this project and I render dock this one, and I like allocate some random chunks, and I just spawn in water on a border, one of these draw calls, if I look at the mesh viewer, I'm not actually sure which one it is. I think it's this one, potentially. Yeah, this draw call is like drawing the sprite to the sort of water map. But if we look at the mesh, it's like the sprite has actually been broken up into 4 quads. And these are like mapped to the specific chunks here. The reason it doesn't match the world is because, well, like a few reasons. So I originally had it matching the world. But the problem is that, well, the big motivator for doing this was multiplayer. Because in multiplayer, when you have multiple people connected to the world, the server will need to simulate the water ultimately, because otherwise the water can diverge just due to like floating point error, latency with just like block updates that could cause, like say there's a wave of water and you place a block, and the first client sees it at like millisecond 0. They're the one that placed it. That the wave will hit that block immediately and bounce away. But the second client might have a 100 millisecond delay between that block actually showing up. And in that time, their water would simulate 100 milliseconds into the future. So you have like error that can just naturally accumulate through all of these various ways. So the server is going to have to like basically force sync all of the clients to have, you know, the universal like truth about what the water looks like. And if you just simulated one giant square, but you have multiple clients connected, you would either need to simulate a giant region around every single client, which could work. But that falls apart that would fall apart if you had two clients like right next to each other, where their like squares of simulation overlap, and then you have like, well, one, you have redundant calculation happening in that overlap area. And two, it's like, okay, now I no longer know which of those overlapping chunks is the true chunk. So if instead I just break up the simulation into just one giant volume and I kind of allocate chunks out of that, I can never have a case where there are two chunks that overlap. So basically it's just a way of ensuring that I can simulate non-square regions, and each chunk I know is just being simulated one time. And that's like how the world works too, because the world is broken up into chunks, and those sort of dynamically load and unload from memory as you move around. And the shape of that isn't guaranteed to be a square either. Because like in Minecraft, obviously it's a square because you look around, you need to be able to see like distant horizon. But in a 2D game, it's like, I need to ensure the chunks that you actually see are loaded. But I have a lot of extra memory that I can use to like load other parts of the world that might be of interest. And I might want to prioritize surface chunks rather than air, because air has nothing in it. So like, I might preload a bunch of chunks along the surface of the world ahead of time, and sort of not load air chunks. And I want the water to be simulated on those surface chunks kind of far away. So by breaking the simulation up into a non-chunk, yeah. So long story short, the chunk system it's a little more expensive to compute too, because I have to do this UV remapping thing. So like there's a function here, like these two functions actually handle taking in a UV with an offset and then like figuring out how that remaps to like where that chunk actually is. And there is some cost with this, because like it's less predictable too, because the GPU I guess can't actually, well, the GPU doesn't do a whole lot of prediction anyway. But it's like, you know, there's an indirection here, which isn't great. But overall, I think it solves more problems than it creates. But then there's just like little edge cases, like spawning in water around borders that you need to deal with. And that's what I spent a lot of last week figuring out. And now I'm just like refiguring out, but in the game. See, like now it's not even spawning water at all. So I'm not unloading the water as I move around, it looks like. Yeah, so like with what you just said, like I've thought about that too. Just like in general, because in the original Vitality that we wrote in Game Maker, we had a water simulation too. But the way we designed that, well, one, we didn't even solve the multiplayer problem really, but the way we were going to solve it back then was that each client would be responsible for like simulating its water, and then the client would upload its water to the server, and then the server would send that to like everyone else. So basically you like, that's just a way of doing the water thing. So instead of the server simulating, it was the clients. With what I have in mind now, the server will simulate and the clients will simulate. But the clients will never send water to the server. It'll always be from server to the client. So like a hacker could never spawn. Well, a hacker could never, like, in theory, spawn water and crash all the clients, because the only way the hacker could spawn water is like, I guess they could abuse like the water spawn function. But yeah, I don't know. I'm sure I'll figure out some of these problems too once I actually go to implement it. But yeah, it's a pain in the ass, to be honest, everything about it. That's why I spent like basically a month on this now. Okay, so let's see. It's like multiplayer in general is just so annoying because you need to like really think about every single thing you do. It's like, oh, who is actually the authority here? And like, you can't guarantee when updates happen anymore. So like your entire game becomes asynchronous. And you have to like really design your game from the ground up, like knowing that it's all like asynchronous like that. It's actually not too much, and it wouldn't be every frame. It would send like maybe once a second or something, or once every couple seconds, because I'm fine with some latency. Because what I was saying is the clients will still simulate their water locally, so that's how you can get the smooth, water flow. So the clients will simulate their water. It's just on certain intervals, the server will like send an updated version of the water, which is the truth. And you might see some like pop in your water during those update intervals. Ideally, those updates would happen to like off-frame chunks, but sometimes they'll have to happen to chunks you're actually looking at. So yeah, the client, if their water has really diverged significantly due to latency or something, you might see like your water pop back into a different position. But the idea is like, I'm not removing all divergence. I'm just like, it's like rubber banding in like Call of Duty. If you play the old Call of Duties where like you move a bit and then the server like has to send, oh wait, you're not supposed to be here actually. You're supposed to be back there. And then you like kind of snap back to where you were. That's kind of how the water is going to work. And the server will simulate a larger, basically just grid of chunks. Basically a grid of chunks big enough to support the number of players connected. But the amount of data that gets sent actually isn't that much. Like, let me figure out how much it is. Uncompressed. So for 4 liquid types, it's just 4 bytes per cell. And there's 64 by 64 per chunk times 4 bytes. So like 16, what was that, 16 kilobytes? Just make sure I did my math right. 64 by 64 times 4 bytes. Yeah, so 16 kilobytes uncompressed. I mean, which isn't a small packet, obviously. But if you're like receiving 16 kilobytes over 1 second for a chunk, I don't think that's that bad. And then compressed, it'll be a lot smaller. So I think it'll be fine. I mean, the alternative is just not having water in the game, or like doing Minecraft style water. And that's lame. So I'm gonna will this into existence one way or the other. But let me figure out what was wrong with this function, because this still wasn't working right. Oh, actually, let me make the water render first, because that's more fun than what I'm doing right now. So let's see. I need to think of the easiest way to just get this water to render onto the world. What's this shader called? We'll write a very basic water visualization shader right now. So we draw the scene, we color grade it, and then we'll just draw the water on top. Each cell holds how much mass of water is in it. And it's 16 kilobytes for the entire chunk. And in view, at the default zoom level, you can only see like 4 chunks at a time because the chunks are 32 by 32 blocks. And the water data is held at double that resolution because there's like 2 water cells per block, or 4, I should say, per block, 2 in the X and 2 in the Y. So total per chunk, there's 64 by 64 like water cells. And each of those cells holds 4 bytes. And that holds the data about how much water there is, how much lava there is, how much oil there is, and then it also has the velocity, the horizontal and vertical velocity of the cell, so that I can do physics on it. And that's all packed into 4 bytes. So 3 of those bytes are just the amount of water, like the water mass. So there's 8 bits for water, 8 bits for lava, 8 bits for oil. And then I pack the velocity into another 8 bits. Because the velocity is pretty coarse. I actually don't need that precise of velocity to do like physics, because I'm interpolating it anyway, so it doesn't need to be like perfect. Okay, so let's see. I want to have 2 of the same like Visual Studio Codes open. Let's remove that. One second. So write this little shader so we can see the water. I'm just going to copy this shader for now. So what is happening upstairs? Let's see. Actually, I need this shader. So we'll make oil green, water, lava, oil, water. This is just a really, really rough shader. Just so we can see something. And it didn't like that. Really not like that. Why? Oh, it's just lying to me, of course. Okay. We see something, but that's not correct. Cool though. We're getting there. Why is that drawing is all black though? Clear color. Shouldn't be clearing the color. That's probably why. Yeah, here we go. But we can make that a little bit better. Aggressive blue, yeah. This is just the debug shader. Just so we can see the water. Because it's easier to debug when you can actually see it. I mean, that's kind of cool seeing it in the game, actually. Because like now at least I have a sense of the scale of things. But the actual making the water look cool is that's a project too. Interestingly, it's kind of bleeding into the blocks a little bit. I don't think that should be happening. I don't know if that's actually a problem though. Maybe that's fine. But yeah, the positioning is not correct. Yeah, I'm gonna do that too. I deleted my ability to change the liquid type, so let me just add that in really quick. So we need to get this back. It's just some random static variable. I don't know what, let's do like VKO is my change my liquid type button. Okay, that did not work. Is it this? Yeah, we're getting there. Terraria 2, that's the goal. No, it's actually not the goal. You know, for making a Terraria game, I've played Terraria a criminally low amount. I don't think I've ever actually beaten Terraria. Like the corruption or whatever. I think that's the thing, you can beat Terraria, right? There's like a boss and stuff. So I've actually not played Terraria very much, which is maybe a problem if I'm like making a game similar to Terraria, because I'm sure there's a lot I could learn about how to make a better Terraria if I've played the original. What's wrong with this? Int. Does this not do anything? This button should definitely be doing something. Oh, it's not going to do anything. Oh yeah, that's just not running. And that would make sense, wouldn't it? Because I would need to like have that perfectly timed with the where's the update function? Let's just put that there. That would be cool. There's a lot you could do with automated testing. Okay, so here we go. Here's the lava. Cool. And the oil, which draws as green right now because, you know, it's just what oil looks like, I guess. It works. Yeah, and again, I'll emphasize, this is the debug shader for drawing, because I'm in the process of adding this. All I care about right now is that I see water that moves, and I immediately see that the collisions are not correct, because we shouldn't be colliding with grass like we are. But the cool part is that, you know, it interacts with the world and I can break stuff and liquid goes flying into caves, which is always cool to see. Place a little barrier here. It's annoying when I left click, I like place a water. So. Yeah, it's very performant actually. Like if I uncap my frame rate, I'm getting like 3,000 frames a second basically. pretty fun actually, playing with the water in the game now. Okay, let me fix, there's a few things I need to fix. Let me fix the collisions first, because it shouldn't be colliding with random stuff in the sky. So let's see, what should that actually be? So I need to be testing against G apparently instead of A. Is that correct? Let me see. Yeah, G. Okay. So this should fix the colliding with grass issue if I just change this to G. Yeah, there we go. Ooh, now it doesn't go in the cave. Interesting. That's kind of odd, actually. I would have expected that to work because the lighting works. What's the lighting using? Well, I guess it's not using that at all, is it? So that uses a... Yeah, I'm gonna make it draw behind the world too. Getting the shader to actually like render the water correctly is gonna be a project in its own right. So right now I'm just drawing it as like cells. I'm actually intrigued. Why isn't that working? Happened. Okay, I think I know what's happening here. Yeah, well, yeah, it shouldn't even be colliding with the background because the background actually doesn't submit any of its information to the graphics card. So I think what's happening is it's not seeing that I'm deleting blocks. Like if I bring up the render target here, you can see I've like carved out this little area. But if I render dock this, all I think happened, if I find whichever one of these is like the actual water, this one. Yeah, see, like, I can see it if I turn the alpha channel on, but otherwise it's still actually containing the old data there, so I need to fix that. So where is that? I need to turn off blending, I believe, is how I would fix that. Let's see. I get lost in this giant script sometimes. Here we go. Yeah, it's like drawing 0, 0, 0, but it has a blend mode enabled, so it's trying to draw it as if there's blending. Whereas it should just be drawing it directly, like this. And there's also another one of these I call. All right, in theory that should fix it. Yeah, there we go. Yeah, it's pretty cool. I'm excited to do the visualization for this too. Because I want to have like reflections and stuff in the water. Okay, I need to do a different key for placing water. This is intense. Let me fix that. One second. Do I have P doing anything? I don't think so. Okay, let's make this the P key. And then let me figure out what's happening here. So I know this isn't correct. Let's make this smaller. I somehow made it red. Oh yeah, that's right. I pressed the key to do that. Yeah, so it should pass through leaves. It should slow down through leaves, so that'd be cool. All right. So it's like off by half or something. Yeah, if I put the mouse through the chunk, it's like off by a factor of 2. Which is odd. I'm not sure what you mean by lose its level. The water is compressible. That's a downside of the algorithm I'm using for the simulation. And that like if I have a ton of water, it'll actually like compress a little bit, which isn't how real water behaves. But like if I add a bunch of water over here, you can see the level on the left side here is like going up to equalize. It's like happening over there too. So like given enough time, this will equalize, which is kind of cool. Let's get some lava in here. Yeah, and like right now the water and the lava don't like create blocks. All right, let me fix this position thing. It's this function again, so let me think what's happening. Yeah, I guess that is true. Technically speaking, water is compressible. Okay, so that times 2 was definitely doing something. So that's necessary. Oops, what'd I do? What's the actual compression of water? I'm curious. Okay, this isn't helpful at all. The compressivity, 5.1 times 10 to the negative 10 pascals. Inverse pascals? How much? Oh yeah, I see what you're saying. Yeah, no, it doesn't soak into the ground. That would be cool though. I've thought about that as like a mechanic. Like if you have to like hydrate the soil to do like farming, but maybe the soil can be like too hydrated for certain crops. Per kilometer. Under 4 kilometers, the water's density is increased by just 1.8%. So it's like half a percent per kilometer of water, which is kind of crazy. Okay, so let's see. My math is off here somewhere. I have a divide by 2. Is it this maybe? Let's just see what happens when I mess with these numbers. Okay, it's not that. Is it this? It has to be this, right? I don't know. I'll figure this out later. My focus is not on that right now. But yeah, that'd be cool if like different blocks had different like water absorption factors or something. I'm going to change the order that this is rendering because I can move this. Let's see, I can move this somewhere else. So like, where do I draw everything else right now? The lighting happens here. Scene primary. Yeah, so like it needs to happen like in here or something. Something crazy is going on upstairs. The annoying thing about this is like, there's like a very particular ordering I want for the water. Like I want the water to render behind the foreground layer of blocks. Like you see how like the grass kind of like juts out a little bit on the side here. But if I place the water right now, let's get like a few blocks in here. Oh, I just ruined my grass. Yeah. Yeah, so like currently the water draws just on top of that. But I also want the player to draw on top. But the water has to draw... It's like I want the water to draw behind that layer, but on top of the player. So I need to like split it up in like 2 passes or something. And like do like a cutout of the foreground for the water. Yeah, I can make it. Let me make it transparent right now. Let's make it, yeah, 0.75. Yeah, again, this is the little debug shader too, so it's gonna look good once I put some time into the actual appearance of it. Like in my little demo thing over here, it looks, I mean, this is, even this is still a debug thing, but it looks a bit better in here because it has like foam and it's smooth in here. So I'm gonna make it smooth in the game too. There's some extra stuff I need to do to get that to work first. I want to make it interact with the lighting as well. So I guess I might as well, let's just start doing that. We can get that done pretty quickly, I think. So I need this shader, the readback shader. Yeah, you can see it when it's transparent. A lot of this I'll probably end up playing with off stream too, because this is just gonna be like sort of a just an iterative tweak things and see if it looks good type process. Okay, so let's see. I'm missing something here. Fluid. What's this thing called again? I always forget. What is happening upstairs? Make sure that compiles. Yeah, let me make it like 60% to 75 might even be too much. Place some lights back here. Yeah. How does your water work again? It's all CPU, right? Yeah, because I remember you were posting some videos on that like a year or two ago while you were working. And I was inspired. Yeah. I almost went CPU water for this too. Like I'm still not fully happy with the GPU thing because it's just like an extra layer of like fuckery, honestly. To like get like things done. It's like, oh, I need to create all these render targets, and the render targets need to be like the right format. Sweet. Okay, let's get the readback stuff working. This is gonna nuke my performance a little bit, getting this in. Because I have, in this, it has to do a CPU readback every so often. Where's the readback? Job readback. And this is a performance killer doing the readbacks, which is sad. Let's get the whole function. I do it infrequently, but you still need to, you pay some cost by doing this. And not a non-insignificant cost. It's like 2 milliseconds per readback, which is a lot, considering the draw call is like, I don't know, 0.01 milliseconds. Yeah, I would have used a compute shader just right away because, yeah, like right now I'm doing this in a fragment shader, which is kind of crazy. It's just that I don't have... yeah, I don't have... I actually don't have access to compute shaders on Mac yet because I still use OpenGL for my Mac build. And I have a MacBook is like my laptop, and I use that a lot because I'm not always at home. So yeah, right. Yeah, so I basically support Mac still as one of my target platforms, and I use OpenGL because I haven't completed the Metal API yet for my rendering. And Apple OpenGL doesn't support compute shaders because they only go up to OpenGL, I think 4.1, and compute came later. So I'm kind of stuck with fragment shaders for now, but I've written it in such a way that it should be like really easy to convert over once I just finish doing the graphics backends. Okay, what am I doing? I keep getting distracted by myself. Yeah, but that's my thought on all of that. Okay, so let me see. What do I need to do here? Copy this. Get rid of the timer stuff. We don't need that. Timer, 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 timer. Hey, how's it going? Yeah, I did start working on the Metal API. I just don't have it like enough to actually run the games. I'm kind of just doing it in the background whenever I'm feeling burnt out from other things. Yeah, I'm working on a game engine and the game at the same time right now. I spent like a year making kind of the base engine, but now I actually want to make stuff. So I'm working on games now. What should this be? It should be resolution. I need to change these. I don't like the names of those. All right, in theory, this should do the readback now. The game is like it's a Terraria clone. It's the one I'm working on right now. And today I'm working on getting the water simulation in, so I'm like right in the middle of doing this. I say Terraria clone, it just looks like Terraria, but it's not really gonna play anything like it, but you can't escape the look, so might as well embrace it. This should have something in it too. Okay, that's sad. There should be stuff in this render target. And ChatGPT, I use it sometimes. Not very often though. I think ChatGPT has gotten worse since like last year. So like a lot of times it's less helpful than it is helpful. I do use it for like random search engine type things. Like if I don't actually know what I'm Googling, it's like really nice. You can just sort of write crap to ChatGPT and it'll figure out what you're trying to say. So one of these, this should have something in it. I don't have ClangD turned on. I have that in my to-dos because it's a lot better. I know of ClangD and I've played with it. I just haven't actually set it up yet. So that is definitely in my to-do list. Yeah, it's way better. I know. It's way faster. It's better for like, yeah, I know. I'm getting there. So what happened here? I don't know what order it's drawing. I think this call is the one. Oh, there is stuff in here. Okay. That's odd. So that's good, actually. Yeah, it's fine. It's fine to answer questions. I enjoy it. I end up going on tangents sometimes. And I'll repeat my tangents multiple times. Okay, so that works. I'm thinking about how to do this, how to implement this. So I just realized one of my ideas isn't actually going to work. Because I changed the way the lighting works. Basically what I wanted to get done really quickly here was get it so that the water interacts with the lighting simulation. So like as you add more water, it gets darker near the bottom. So the lighting has to read from the water data, of course, for that to work. And I thought I could just like easily kind of cheese that, but it looks like I can't do that. Yeah, I just use VS Code a lot of the time. Like I just run the debugger here. Well, it's not going to attach because I'm in release mode. I use Visual Studio Code, or just Visual Studio, when I need to like debug more intensely than just breakpoints. Because I hate Visual Studio, like as an IDE, because it's just really like, I don't know, I hate working in Visual Studio because it's always super slow. But the debugger is a lot better than the built-in VS Code one. Yeah, it's kind of, I hate that that's true, because I hate opening up Visual Studio to do things. Yeah, it's super clunky. Okay, let's see. Wait, I'm actually, maybe this was fine. Let me just add a bunch of water. Yeah, I'm kind of like scatterbrained at the moment, if you can't tell. For anyone who just joined, so like this is the game I'm working on. And last week, I was working on the water simulation sort of in isolation in a separate project. So this is like the actual just simulation as a standalone thing while I was working on like the physics for it. So today I'm actually taking all of this and then putting it into the game, which is pretty straightforward. I just need to like change some of the stuff that's placeholder in this project over to like the game's more proper systems. I'm not sure why the water's acting kind of weird. But like this standalone thing didn't have the lighting in it. So, and yeah, that's why it looks kind of crappy right now. Like it's really pixelated. Because this is just like really fresh hot off the press right now. No, I didn't even do what I wanted to do. Oh yeah, Linux too. Yeah. Yeah, my engine works in Linux, on Linux. So like I've made it work cross-platform. And I have a Linux dedicated computer that I run. Well, actually, my Linux has corrupted itself. I tried to sudo pacman update all of my apps, and it segfaulted during the update somehow, and I can't boot into Linux anymore. And I just haven't had the motivation to fix that. So I've currently bricked my Linux computer somehow. So, yeah, I have literally no idea what happened. I was just like updating, and then like it literally showed me like a seg fault within the, the terminal. And then I rebooted Linux, and I just can't even boot into the OS anymore. So I don't know what happened. It was probably something I did, realistically. Like, who knows? But that's always, that's just Linux for you. I've installed Linux so many times. I love Linux for how like lightweight it is, and you can just like install it and run it. And it's customizable, and like Linux, that's just Linux. But when it comes to stability, I just always have problems. So I don't know what I'm doing wrong. I need to come up with a better way of debugging this. Okay, actually this will be fine. I thought this wasn't going to be good. The other problem is I was running Arch as well. Because so I'm not a big Linux like guy myself. I don't know. I'm like I have working competency in Linux because I've used it a little bit now. But like I was never a Linux guy. But one of my friends is like really into Linux, so he was the one that kind of nagged me to get into it, and he was the one who helped me install Arch. So I think we just messed that up, honestly, and that's the story there. Okay, so I have this buffer now that I can just send to the water shader. So the lighting shader. So let's just take this in as another input. And what I'm going to do is I'm going to add light where there is lava, because that should look cool. And this will be a good way of just making me know that any of this works at all. So let me see. Let me grab this as well, fluid. So I think lava is in... We'll even do this with a branch, because who cares? So if the fluid has lava, then we just add red light. That seems logical to me. Let's see. Where do we call this? I have a lot of textures here, don't I? In theory, this should just work on the first try. In practice, I don't know if that's going to be true. It's not looking that way. Dang it. Wait, I guess that's expected. It's packed, isn't it? I need to unpack that. So, unpack mass, I guess, is the function I need. Okay, yeah, there's a few problems with this, actually. So that's just that. So this might work. Yeah, there we go. There we go. A little bright, but the lava glows. Very bright. Very bright red. Okay, I'm very happy that that just worked with like the second try. That that validates the couple hours I spent earlier in the week getting the lighting thing to work the same way the water does. Yeah, because let me make the intensity less bright though. So this should be like max, or actually it should be like saturate the source redness plus some constant. Some redness factor, so we'll make it like 0.6. So this will make the red less intense. Or I can make the brightness a variable based on how much mass there is too. It's an option. I really need to fix the mouse. Let's make it night as well. So you get like really just bright red lava. So if we had some other lights. Maybe the lava should be more of an orange color too. So let me make like lava color. Color lava. What is orange in RGB? I'm not even sure. So it's just some of the second channel. We'll multiply it by the lava's mass as well. Okay, maybe a little bit too yellow. Certainly too yellow. That's odd. Why'd that become so yellow? 0.3. Is 0.3 just too much? Let's make it a little less intense too. Oh, I guess I see what's happening. It's like adding essentially white light because I'm using like a saturate rather than like forcing the color. So yeah, this is the problem. So I should use like max, I think. Yeah, there we go. It's kind of a fun glowing red color. Now it's almost too dim. I really need to fix the mouse. It's hard to place the water. Alright. But first, I'm going for a nice like orange light is the goal. Now you can't see the player at all through the lava, which is odd. Okay, I'm gonna take a second to figure out this mouse issue. I need to actually think about this instead of just hoping it'll work by tweaking numbers. Okay, so I call this function and I pass it the half block position, which should get mapped to a chunk based on, okay, so that's X, and then the width and the height is in floating point, which is kind of annoying. But these would still be in 64 divisions, I believe, because that's my actual resolution here. And then those get passed to this function, which will map it to the chunk grid itself. So that's the average divided by that. And that gets the chunk, and then it remaps it. I think it's this part that's not right then. Because it should be this, I believe. Yeah, there we go. Now it's fixed. I don't really know if I have one off the top of my head. I think the main one people use is GLM, I think. Is that the correct one? Let me Google that. I guess that's OpenGL. What's the other one people use? There's like a common one people use. I that's not helpful telling you that, but in my engine, I don't use a math library. I just kind of wrote the functions because I don't really use that much math for the rendering stuff. I just have like matrices 4x4 and vectors, and that's it. So that's all I've needed. Yeah, I think GLM is the one people usually recommend. That's the only like actual math library I've experienced with as well, like outside of just rolling my own. I wouldn't recommend rolling your own though. So don't do what I'm doing if you actually care about like writing a robust math library. Yeah. Yeah, you can write your own math library, but there's a lot of optimizations that, you know, the true and tested ones use. So, yeah. Is eigen the one, I think I'm pronouncing that right. They have like quaternions and stuff, don't they? I think GLM does as well. It's like a standard math library supporting feature, but a standard thing people need in a math library. But I just remember that stands out to me for like quaternions, I think. Maybe I'm just associating that in my head. Super satisfying that this works. Okay, what else do I need to do? I need to make the light lose value based on whether it has water in it or not. Pack the oil. I need a bit shift for the oil too, it looks like. Yeah, because I want the water to make the lighting go darker. So that should just be a matter of let me think. Translucency, this function. This should be a function, to be honest. I'm not sure how I want to reduce that. I think one of the main problems I'm gonna have is that the water wants to or the light wants to bleed through the back of the water too. Which I guess makes sense. It should just be lit up if that's happening. But that's not really the effect I wanted. Let's just try and see how that looks. So I'll also have something like this. It's hard to tell if it's getting darker. I think it is. But not quick enough. In fact, I'm not sure if that's working at all. Maybe I need to do this here. All right, that kind of works. It's kind of dumb though. When you break a block, it's like it just suddenly shoots in the brightness, which is kind of dumb. That is getting closer to the effect I want though. I think maybe water should fully remove the background light. That looks pretty dumb too. So maybe not fully. Yeah, I agree with that. This is getting closer to the effect I'm after though, with the water and the light. Basically the water like kind of mutes the lighting the deeper you are. Maybe it should go, maybe the fall off shouldn't be as steep because it gets dark pretty quickly. I was thinking it would retain its brightness for a little while. Like this doesn't look great. If you place lights down here, then you get like the cool lit up effect. I'm gonna make the water a bit darker. Yeah, soon I'll start the actual, get the proper visualization back in here. Because yeah, the current coloring isn't very good for seeing what's happening. Yeah, I actually do have a channel free right now. Yeah, because I use red for, the red channel is for water. I think the green channel is for lava, and the blue one is for oil. So I still have the alpha channel free at the moment. And I wasn't sure if I wanted to do another, like, liquid type. Or there's, like, other simulations I could do, too. With that extra channel. So I kind of have it reserved right now for anything else I come up with. Yeah, it's kind of dumb how it flashes at you when you break blocks. Yeah, that's a good point. Okay, now that I fixed I fixed the mouse thing, I can get the other hotkeys in here too. Because I had a fun hotkey that makes it so you can create a little geyser thing. So I'm gonna add that back in because that's a fun one. Yeah, here we go. Here's the geyser. It's a little weird. Let me let the water settle down. Let's add some oil. Yeah, you can have little fountains and stuff. I'm excited to actually work on gameplay features with this. You can have like a pump that like shoots out water. I didn't mean to do lava. All right, I'll start working on the improved visuals, so we get more of the proper effect here. Because yeah, this isn't great, to say the least. The colors just look bad, so let's fix that. So we need some stuff for that. I think I have this already in here. So let me just see what that looks like. So I basically need these shaders now, because these are my visualization shaders. I'm gonna need to fix stuff with these too, I believe. Mission chunks. These actually might work right off the bat. Or no, probably not. Where'd they go? Yeah. So we just need a new function in here somewhere, like that. I'll start with the water first. The water and the oil, and then the lava I'll do second. So we do this one. So have to see what the flow is here for actually rendering these, because it's just these two shaders, so I just need these basically in here. I need like two of these surfaces. So like visualize water, oil, visualize lava. So then I just need some sort of should not be constant. So I need to update this. I think that will work. It's hard to know. Let's see what happens. Let me just double check. Because that draws it to basically a surface that will contain the water all stitched together. And then this one draws it within the world with interpolation. And then all I need to do in theory is replace this in here with draw. And that has the correct matrix already. And this one should be like prepare. Yeah, there we go. Wow. That amazingly worked on the first try. How was that possible? That's crazy. All right. Wow. I was not expecting that. I was doing some crazy math. I'm just getting so good at doing random chunk math, I guess. You surprise yourself sometimes. Yeah, it looks pretty dumb though how it overhangs the blocks like this though. So I need to fix that. We lost the transparency. And then just in general, it looks kind of weird, actually. I think it's the lighting, though. So in theory, the oil works, too. Yeah. So let me get the lava working too then right away. And I should just abstract this into a little function as well. Let's make it like a lambda. So I'm going to use this twice. Yeah, I run on Mac too, because I have a MacBook as like my main laptop, but I just use VS Code for it. So we need to capture these or send in, I think it's this. You can just send in this. Lambda expressions are crazy, actually. I'm like just starting to use them frequently. And they are insane. They are cracked, for lack of a better term. Because look at that, you can just do that. It's crazy. Alright, so now we can do the oil. I mean the lava. But yeah, I use VS Code on Mac as well. And on Linux too, I just use it everywhere. I kind of like just having like one thing that I just use everywhere. I use the VS Code debugger on Mac. I can run with Xcode. Like it does work. I just don't like Xcode for the same reason I don't like Visual Studio. I can't do graphics debugging though, which is really annoying, because RenderDoc doesn't work on Mac. So you're like forced to use the Xcode graphics debugger, but they removed the support, or I guess I don't know if they ever supported it, You can't do graphics captures with OpenGL on Mac. So that's another reason I'm doing Metal. One of many reasons. Okay, so we need this one. I should rename these shaders. These are not very good names. It's kind of dumb to like rebind everything too. I should just like combine these to 2 render targets. I'll do that in the future. Yeah, that's what's cool about Xcode, is that you can do that. Uh-oh, what happened? I broke something in the process of doing, oh, I see what happened. I remember I have a debug visualization of the walls in the lava shader. Where is it? Visualize lava, I need to get rid of this. Yeah, there we go. We still have the lighting too, which is neat. Yeah, I have the same experience. Yeah, the M1 machines are, the M1 chips, or the, I guess the M chips, they're actually like really fast. Yeah, because like I was never a big Mac person until a couple years ago when I got one of the M1. I got the M1 Air. It was like my first sort of Mac computer. And it was like, I hate to say it, but it was like the first laptop I've ever owned that actually just like works. I mean, Apple does have a lot of quirks to it. Like the Mac operating system definitely has its quirks. But once you like kind of get used to those, it's actually pretty good. Yeah. And like, yeah, so like I have a MacBook Pro now. I ended up upgrading because I liked it so much. Yeah, I have like a love-hate relationship with Apple devices. I have a lighting bug with the chunk corners too, it looks like. Yeah, Finder, the file system in general. Yeah. Yeah, I hate Finder. Like, the thing is, the file system doesn't have to be bad because it's like based on like POSIX, right? Like internally, which is the same thing I guess Linux uses. But yeah, the Finder is just, yeah, it sucks. So satisfying that this just works. I thought this was going to be a bit more painful than it was, in all honesty. I will. Yes, I will. I'm gonna do that today. That's kind of my next step. I'm gonna go in and clean up a lot of that stuff. Cause yeah, it's I'll get it working and I'll just like never be able to fix it because I'll be afraid to touch anything. Yeah, it's hard to avoid sometimes. It's like, I don't know. It's like there are magic numbers, but it's like numbers I know I will never change. But I guess just even putting them behind like a variable or something. So at least they have a name. Because otherwise, yeah, it's impossible to debug some of that stuff sometimes. Yeah, exactly. It's like I still have this thing ingrained in me where like putting something in a variable, like I think it will make it like slower or something. But obviously that's not true because the compiler just comes in and, you know, optimizes it anyway. Like it literally doesn't make any difference. But for some reason I just like feel like it adds cost even though I know like objectively that's not true. Yeah, I need to make the water look actually good. Looks kind of weird. Yeah. I don't know how the compiler gods do optimizations. It's actually insane some of the stuff that the compilers do. I'm curious like what kind of like heuristics go into it as well. Oh no, not Java. Yeah, Java's horrible. Man, this is just really fun to play with. So cool having like water physics. What's my FPS sitting at now? Okay. Not too bad. I'm gonna make the water transparent again. Water. I'm just gonna see what it looks like with the water in the background. Or in between the layers. This is how I want it to actually look. But there's certain things that need to be drawn. Yeah, I will. Even this water visualization is still like a debug one. It's just a slightly better debug one. Yeah, because the actual water will have like reflections and, you know, like UV warping. I'm just thinking how I want to do the layers for this. Like layering the water into the world. Because I think this looks better. It's just right now it's like either blocks are on the foreground or they're on the background. Whereas like here there's grass, but like the water should draw in front of this like tall grass, but behind this front layer of blocks, I think. Because I think this looks a little better. So I'm gonna need to change that. I'm just gonna like need to go in and have a think about how to actually like composite all of these rendering layers together. I'm gonna turn off the weird lighting effect on the water too. Doesn't look good. Make sure if I teleport around, the water does not get deleted. Yeah, so here's a bug. If I teleport around, the water sticks with the camera a little bit. I'm not clearing the water. That's funny. I wonder why that happens. Yeah, it does. I can demonstrate that really quickly. If I just build like a little, you know, U-shaped thing. Had a bunch of water over here. Oops, didn't mean to do lava. Maybe it's not the best example because I just had some velocity there. Well, yeah, the water shouldn't teleport at all. I think it's like lagging. The simulation isn't lagging, or it's like lagging behind the position update. I need to fix that. I think I know what's happening though. Here, let me zoom in. Let's try a better example of the pressure. So if I have like a little wall, put a bunch of water and let it settle for a second, and then we slowly yeah, you can see it levels itself over time. So yeah, it simulates pressure as part of its simulation. I'm gonna spend more time just playing with the water than I am fixing the bugs that are there. Okay, let's fix some of these bugs. Why is the water teleporting with the camera? I think I know the issue. It's just not clearing when it like reassigns a chunk. It's not clearing the old data from it. So that's an easy fix. Let's see. Where do I assign? So I just need to do something in here. Let's see. I need like a function that does something. Yeah, working in the world now. A few bugs though, I'm working out. This is gonna be a kind of a long process, getting it fully integrated. It's really cool though. I'm excited. Obviously the physics aren't doing anything, like with the player. And the lighting needs some work too. I have it so the lava works with the lighting though, so like if I place lava, it like glows, which is really fun. It's pretty fast. Like if I uncap my frame rate right now, I get about 2600 frames a second. I think there's room for optimization though, because I have some inefficiencies in here. So it's really fast. It's really performant. Like if we render dock the timing of these, it's a 3080 RTX 3080, so it's a higher end card, of course. Let's get some lava in here. I don't fully trust the render dock timings, but it gives me an idea of like what we're working with. Yeah, so like each thing is dispatched as a draw call. So like each step of the simulation. So these like top ones here are the lighting. Nothing's really happening, but each of those is taking according to RenderDoc, about 18, 19 microseconds. And then the water simulation is here. So each of those seem to take about 100 microseconds, roughly. And there's 4 of those per frame. Well, 6 of those per frame. Yeah. Yeah, so the lighting system's kind of interesting, actually. It basically works, in this engine, it kind of works like a gas, for lack of a better explanation. So you can kind of see, if I close RenderDoc, and I can open up one of these render targets so you can see what it looks like. Might be a bit hard to see because it's tiny on the live stream, but if I, at my mouse, let's make it nighttime. So like, when I press a key, I can have like a little spotlight in my mouse, or a point light. If you look at the render target, you see how it like kind of lags a little bit as I wiggle my mouse. So the lighting is just like a kind of a cellular automata type gas, I guess. It kind of like behaves like a gas because it goes around corners. So yeah, it just simulates on a grid, just propagates out its RGB values, essentially, like in the most basic sense. Yeah, so it's not that complicated. What's cool is I can like place stained glass. So here's like a stained glass block. As you can see how it like tints the color, the light color. Yeah, right now it's just contributing light to this sort of simulation grid wherever the lava is. So if I place some lava, you can kind of see like, it's like points of light in that grid. And then it just propagates out from that. So basically every lava tile, I guess, is like a light source. And what's cool is that since the water and the lighting are both done on the GPU, and they both like use the same resolution simulation grid thing, it's like basically free to do that, other than like a texture read by the lighting shader. So the lighting shader just sees like, is there lava in this tile? If there is, it just adds, you know, lava color light. So it was like, it costs like basically nothing to make that work, which was really, really cool. Alright, I forget what I was doing. What was I just doing? Yeah. Yeah, and I'm sure I could kind of like tune this indefinitely to make it look even better. Eventually I'm gonna have to just like decide that it looks good enough and move on. What was I working on? Oh yeah, I was working on fixing that water issue. Yeah, so right now I have an issue where if I like add water and I teleport just like suddenly, the water kind of like teleports with me, which shouldn't be happening. And I know why it's happening, I just have to fix it. So let's see. Where's my other project? Actually, this isn't correct. Not really. It's more complicated than sand. It's complicated because there's like vortices and stuff, and pressure. Whereas like sand is a little easier to simulate because you just kind of goes like down into the side. No, I didn't mean to. Okay. Yeah, so like as a basic overview of how the simulation works, there's basically a velocity field that's simulated in a grid, like of cells, I call them. There's like a grid of water tiles. And then, so there's a velocity field, and then there's, each cell has a mass, and so it has a mass, a velocity, and a pressure. Those three, like, or four components, like velocity X, velocity Y, pressure, mass. So it does in the simulation works on two phases that flip-flop back and forth. So one phase treats the water as a particle, and basically, so each cell is treated like a particle. And it does forces against other nearby particles, or the particles directly adjacent to it. And then the second pass takes the cell that's like represented as a particle and then puts it back onto the grid. So I'm not actually simulating particles, I'm simulating water on a grid, which is nice because particles that actually freely move around the space are like a real pain in the ass. And there are water simulations that do that successfully. It's just like really, it's a lot more complicated to do that. So mine's like sort of a pseudo, it's like a mix between a particle and like cellular automata, basically. And I didn't invent the technique. I was following a technique implemented by, let me see. I can maybe like link it in the chat. Let's see. Because it is interesting. Let's see. Found it. I guess you can't see it, chat. I'll paste it in the Twitch chat. If they'll even let me post links in my own chat, we'll see. I can hear myself. Yeah, this is like the technique I most closely followed. Was the work from this guy. Mine's different in quite a few ways, but like the general principle is basically what he implemented. Okay, so this actually isn't, I need to like abstract this slightly. That's one way of doing it. Okay, I don't think that worked, unfortunately. Let me make sure. What happened? Something's off. I saw water flying in from the side of my screen, which is never a good sign. Let's see. Mass. Let's look at the mass simulation. There's nothing to see there. Velocity, maybe? Or pressure? Probably has something. Yeah, there we go. There's some pressure in there. Maybe when I release the chunk, it should do that. Okay, that did not work. These should be empty. When I teleport around, the color here should disappear. Is what the objective is. It's possible I didn't do this correctly. So simulation, volume, size. I mean, that shouldn't go wrong. Actually, don't need to send in that. Yeah, I have no idea how they do their water. Sometimes I go into Terraria and like Starbound. Well, I say sometimes as if this is like something I do all the time. Recently, while I was working on this, I did go in there and like mess with their water a bit just to see like what they do. Just like visually. Which is fun. It wasn't too insightful though. Is this code even running? Is lava, is honey. What happens in that game when like honey collides with water? Like what happens to the honey and the water? Do they just stay like separate? Because like fluid interactions are really annoying. Is like my biggest takeaway from all of this. Okay, that is running. It's just not drawing anything, maybe. Or not drawing in the right spot. Just make these draw full white until something happens. Yeah. I guess that makes sense. Like the honey cools down into a solid block of honey or something. Okay, I don't think these functions are working. Okay, what could be wrong? Oh, maybe this should be a rectangle, not a... Otherwise it's not drawing anything. Yeah, there we go. I'm seeing white flashing by now. We can put these in here too. Call this like... Yeah, because one of the things I wanted for this simulation was for, well, one of my goals when I started this was I wanted the oil to like float on top of the water. And like if the oil was underneath the water, in the ideal world, I wanted the oil to like float up to the surface like it does in real life. But unfortunately, I can't actually do that easily with the simulation like method. Because once the oil and the water mix, they kind of just become like the same fluid. So you can like see the gradient where there's more water than oil, but I can't like force the oil particles to go to the surface and the water to go down. Because like I was saying earlier, I don't actually have particles here. So the only way to make that happen would be to like completely duplicate the simulation into like 2 different simulations, which would be too expensive for like the effect. So I'm just kind of dealing with the fact that the oil doesn't self-separate, like, because it looks good enough most of the time, but like I know it doesn't separate, so it annoys me. Like I think most people wouldn't even care, but I care. But I'll get over it. Okay, so now if I teleport, I don't see water. It's a good sign. Teleport again, no water. All right, cool. All right, I'll be back in 1 second. I'm gonna go get something to drink. All right, I'm back. Okay, I'm gonna do a bit of cleanup now that we have this somewhat working. So we need like a... trying to think. How do I want to clean some of this up? Oh, folks just didn't exist. Interesting. What other magic numbers can I stomp? Yeah, there we go. That's a nice orange color. I like that one. Oh, I didn't realize the mask goes above 1. Interesting. Maybe it shouldn't do that. Okay, I'm gonna fix the layering of the rendering. This is gonna be kind of tricky, actually. Because I basically need to be able to draw the blocks in front of the water. While also somehow drawing the player in front of the blocks. Unless, what does the player look like when it's drawn behind the blocks, actually? Maybe that's fine. It's like I need two foreground layers, basically. Because this is what it looks like the player draws like behind the block. If you get up next to one. Which looks a bit odd, I think. Well, I guess it doesn't look too bad. Maybe I'll just keep it like that. But I need to be able to split up the foreground into like 2 layers. Not sure why I just lost video. Why does my cat think it's a good idea to play with the the balls right now? That's funny. Okay. Okay, so that still works. And then if we do this, we shouldn't see the foreground. Well, we might still see it. Yeah. Okay, there we go. I think that works, actually. So the, oops. It's kind of hard to see, maybe. But the water draws behind like the foreground blocks, but in front of foreground plants, except for these over here, which I need to fix. So I need to get the right depth for these. Yeah, there we go. Sweet. I should really figure out why transparent blocks don't work as well while I'm doing this rendering code. Let's see. Because the fluid transparency works, the block transparency doesn't, for some reason. But yeah, I think I'm gonna end the stream. I'm getting hungry, and I'm happy with this progress so far. I succeeded in getting the fluid to work in the game, but still a lot of work to do, so that'll be for another time. So yeah, thank you all for watching. I'm not sure who's all still here, but it's been fun, and I'll stream again soon. See you guys.